All right, so I guess let's get started. Welcome back, everyone. So, yeah, and I guess obligatory disclosure. So today we're going to be talking a little bit about software design. This is genuinely an entire discipline and field into itself. This is just going to be a high-level overview on ways you can organize your program or things to keep in mind when you are writing code to make it a little bit more readable and a little bit easier to work with. And understandably, this is also a extremely opinionated design area. So, like we're going to be talking about things you can do, not necessarily going to be pushing one direction of design or the other. Everything's different, every problem is different, and everyone's opinion is different. All right, so, like, where would I start with software design? It's probably also worth explaining, like, exactly what this is, right? So, I guess in short, so if you were to look at an application from a couple different pieces, you have the portion where you are actually going ahead and building and implementing it. You have the portion where, and you also have the portion where you are designing it, right? So when you are actually going through the design portion, like the thought process is you're sitting down, you're like, okay, I need to accomplish the following goals. I need to do the following task. I need to meet the following set of requirements. And also, how would I like to, technically, if you ask some people, this can actually be broken up in two areas, but for purposes of this, we'll just combine it into one. But you may also ask, it's like, okay, what exactly do I need in order to accomplish the requirements that I need in order to make this happen, right? Like I need to get an input from a user. Okay, how am I going to handle that? Okay, I need to present something on a day of a week. Okay, what components, what libraries, what details do I require in order to make this happen? And my favorite part of this is this could be a couple-minute plan, or it could be multiple hours involving a team of people sitting on a call. Yeah, like it genuinely, it entirely depends upon what's being built, the complexity, and the scale of it. And also something that's really important to keep in mind here. Yeah, and so also something that's really important to keep in mind here is all because your code is more readable does not necessarily mean it works better. Like, genuinely, your code could be next to impossible to read, and if it works perfectly fine, nobody's going to touch it for 5, 10 years in some cases. Now, when someone does have to touch it, that's going to be a little more tricky. But that's kind of the key part of this is more readable code does not necessarily mean it works better, right? Okay. And also have to emphasize, and this is, I'll admit, partially a professional opinion, but it's one of the things that separates a developer who is okay, who can get something built, from someone who is exceptional, right? Like, if you are thinking ahead on what your application needs to do, how you're going to do it, all the pieces that are available to you, and all the requirements you need in order to actually make it happen, you don't have to go back and rework things as much. You don't introduce new bugs because it's some behavior you weren't expecting, or at least you're much less likely to. Everyone makes bugs. And in general, you'll likely get it done faster if you take a minute to sit down and plan out a design, even if it's just a 5-minute sketch on a piece of paper. Having a rough idea on where things should go and how they should work makes you a much, much better developer. And also a key part here, if you're working on a team or you're working with other people, this is pretty much a requirement. You can't start building out an application without talking with everyone else about how you're going to build it. Otherwise, nobody's on the same page with how the application's being built, and you end up with code that doesn't interact with each other and a lot of rework. Speaking from experience I have seen this one happen before in some smaller teams in a past life. All right. And I guess here's a decent, okay, let me check something real quick. Right, okay, apologies. So, why is this important? And I apologize, I thought I had something that was telling me something was wrong with my desktop machine. So why is this important? So the reason this is important is, in addition to all those topics there, right, is at first when you're working on a pretty relatively simple problem, something you can solve in about 5–10 minutes, the design is not that important. It's important, but it's not that important. However, the more complex the problem gets, the more pieces that are involved and the more people that are involved, the harder it gets to actually go through and solve the issue, and the harder it is to immediately visualize and kind of code and then work your way through to the problem. Yeah, and that's, like, I have to emphasize, right? Like, it can be extremely tempting to jump into programming something immediately. And speaking from experience, there are some times where this actually is a completely valid approach. Like, I can name times where I've been like, I've got a pretty good idea what the problem's going to be. I know it's only going to take me an hour to write. I'm just going to go ahead and write this. 99.9% sure this is exactly what's needed. I'll go ahead and do it. But there are other times where it's like, okay, maybe we need to actually step back and think about exactly how this is designed and how this works. So that way we don't have any issues, right? Or so we have fewer issues. That's kind of the thing, right? By stepping back and figuring out exactly how to work on this, or exactly how you want to implement it, it'll save you time later. All right. And of course, if the design isn't great, then you're probably going to end up with a lot of bugs. Or you're going to end up with more bugs because you're going to have to rewrite previous code you wrote that was working. And speaking from experience on this, genuinely before have made a design decision, it worked perfectly except for one requirement. I go ahead and change the piece of code, and I introduce 2–3 new bugs in the process, and have to go back through and rewrite this entire section. I have genuinely lost days before due to design changes like that. And also, I guess this is kind of an important one to note, is the more senior you become in the industry, the more important these design skills are. Because whenever you're just starting off and you're just building programs more junior, you're likely not going to be dealing with a problem that's so complex that you're going to engineer yourself into a corner. Or you'll have someone more senior standing by being like, okay, let's not design it this way, let's do it this. So the longer you're in the industry, the more important it becomes. That's also to say that you're not expected to know how all of it works immediately. Life is about learning. Okay, so with all that being said, we're going to cover a couple high-level organizational concepts and just a couple best practices. So we've kind of talked a little bit about this before, but this has been more confined and to workshops, right? So oftentimes when we will work out a solution, we will want to have a block of reusable code, right? This is referred to as a function or a method, depending upon the language terminology you are using. So that's also a very good way in order to, one of the biggest reasons you would use that is you want to avoid duplicating your code. The other reason you would use that is because you want to keep a group of logic specifically together. It might be like, oh, okay, I want a bit of logic here in order to handle text parsing, or I want a bit of logic here in order to handle rendering a window. I probably don't need that logic scattered throughout the entire program. I probably just want it in one place, ideally. So, it's a good way in order to avoid issues. Well, more specifically, it's a good way in order to avoid copying and pasting code. And it's probably also worth mentioning why you don't want to copy paste it. One of the biggest reasons you don't want to copy and paste your solution is because if you copy and paste it and you have to change something after the fact, then you're going to have to change it in every single location. And there is a very high chance that you miss at least one area, even with something like a find and replace. All right. And also need to emphasize this. Ideally, you keep your functions and methods short and you name them exactly what they're doing, or relatively specific. Like, you should be able to read the method name and understand exactly what the code is doing, or at least have a pretty good idea. If you don't know, that's when comments and the like come into effect. Like for example, we have a method here named getUserInput adding 3. Okay, so what's this going to do? So I can infer I'm going to get the user input. And I'm going to assume this also has something to do with adding 3 to it, right? So we've got our basic logic here. But let's say we wanted to also put a bunch of logic in for validation. We could duplicate this validation logic throughout our program. That doesn't really make a whole lot of sense. We might as well just contain it all in this one function. So that way we can just call this function slash method and save ourselves the trouble, right? You know, basically save ourselves the headache of having to figure out all these moving pieces and just bring it down to one concise moving piece that we know works. Yeah. Another example here. Let's say we wanted to add 3 here. Yeah, same concept. Add 3 to user input. There is technically an argument here on whether or not we should be using 3 as a word or 3 as the number itself. I'll leave that up to debate among the class. I will recommend you don't put emojis in your method names, even though some languages will let you do that. Okay. And so some context is needed on this. We, at one point in time in the classes, and I believe these are still here, had a method in place, which was an example for subtraction, but it was actually doing addition. This actually caused enough confusion that we ended up having to clarify it during classes. And as a result, we ended up using this as an example. Also shows that, you know, even as someone who's worked in this field for a very long time, I think I'm around 10 years in the industry at this point. Even people like us will sometimes make mistakes with how we name functions or methods or organize code. All right. Another guideline is if you can't understand what the function does, at a glance, it's probably too complex. If I were to read this, I have no idea what this is supposed to do. This means it probably would need to be broken up into multiple methods slash functions. Do we have any questions so far on this? All right. So that kind of summarizes a lot of like the idea of like, you know, functions, everything on. You can get pretty far with understanding how to organize those and work with those. Classes in general, a common use case for them is you use them to organize your code, right? So like here's a example of it, right? So like for example, if we were to define a class and the class were named cat, we would want the class to do one thing, right? We want the class to be responsible for one thing or specific area. So for example, it probably makes sense for the cat to have a meow method. Probably doesn't make sense for the cat to have a method called do my taxes, and I'm not sure I'd trust my cat with my taxes. But yeah, as an example of something that really shouldn't be in the same place. The example we have in the text above is an animal class. In that class, we want to define the animals. We probably don't want to define the functionality for a wall in our game world, right? Doesn't really make much sense to include all that logic in one class. And I had to put a giant caveat on this. There are occasionally, in some design patterns, cases where people will use a class to manage the state or basically provide a container for all the variables they're running throughout their program. or specifically an area of their program, that is fine. In that scenario, it is the state itself is the purpose of the class. It is the representation of an environment. So it's more like keeping a representation of the functionality that you intend to accomplish by the class. This is just a general thought process on classes, but in general, a class should be open to extension. So you like, for example, if you inherit from it, you should be able to extend its functionality. You shouldn't, and ideally should avoid, modifying the, well, should avoid ideally modifying it. And what I mean by this is, if I add a new functionality, I shouldn't change the existing class behavior for what is already there. Rather, I should really only add the functionality. And this also gets into the comment at the beginning of this class where this is going to have an opinion. Like, this is opinionated, right? Like, this is a scenario where, in general, this might make sense, but there might be exceptions where this doesn't make sense at all. Maybe there are cases where you do want to overwrite the behavior. As long as you're aware that that's potentially going to make it a little more difficult to read. Yeah, design trade-offs, etc. Like, would it make more sense to overwrite the behavior, or would it make more sense to implement an entirely new class that has half the code duplicated? It's a judgment call at the end of the day. This whole thing is just general guidelines, not really hard and fast rules. Okay. A note on a child class. Child class should be reusable with its parent, right? So I should be able to use the player attack. For example, I should be able to use a player attack in the same capacity as something which extends from it, such as the archer class, right? And logically speaking, if I've kept the original methods, I should be able to, right? I should be able to drop it in and use it equivalently. This is really all about both of these points here are primary, like all of these points here. Like this point here on keeping your functionality group together is very much a readability piece. It's that way when you read through the code, you understand at a glance from looking at the class, similar to how you would with a method or a function, what its intent is. One of the reasons that you would want to restrict the modification of the class itself is to help you with reuse. It does help with readability, but it does also help a lot with reuse. Same concept here. By still being able to use the class in the same context, we're able to reuse it where we need to, right? It's like, for example, if this were a game world, or this were a game, I would be able to drop in a player class, an archer class, regardless of what it extends, and I would be able to use it in the same world, right? Like, let's say I had a class that was named game object, hypothetically, right? Okay. Everything that extends game object should be able to exist in the game world, right? Same concept. Logic on that being, you would have like some methods inside of your game object that are required for it to actually function in the larger world. Do we have any questions on that part? Because I realize classes is definitely a bit of a jump on organizational side. Go for it.
So backing it up a little bit, when you were discussing it about instead of correcting like one of the lines or whatever to just right in front of it, you never want to go back to like do anything. So if it's like a small correction, would it be worth correcting the previous or just moving forward from it?
So what you're suggesting is like, for example, if we had a, so you're referring to, okay, so you're saying if there's a mistake in an older part of the program and I were to go ahead and change that portion of the program, would it make more sense to change it, or would it make more sense to work past the behavior?
Yeah, because I mean, would it be better to change it and risking a collapse, or would you just move forward and just try to correct it along the way? with another line?
That is a really good question, and I'm really glad you asked that. So, an answer probably a lot of people don't want to hear is it depends. So, like, for example, let's say I wrote something like a library, right? And the library is intended to be reused by developers. Let's say I have hypothetically 2,000 projects using this library. In that scenario, me changing the behavior of the code I've implemented will legitimately break everyone's code. It probably doesn't make a whole lot of sense for me to go ahead and make that change in that scenario. There are a couple fairly high-profile scenarios where developers went in and changed the behavior of a method or a function. In fact, in this scenario, it would actually be a function for the example I'm going to use. And it actually resulted in breakage across a large number of the existing programming ecosystem. Like, for example, in Linux, there is a library called glibc, commonly used. Well, it's the primary C library. Many, many years ago, somebody made a change to glibc, and this is a whole conversation. I don't want to get into the details on it, but it involved how it handled memory effectively at a very high level. This change resulted in breakage across a large number of projects, including Flash Player at the time. That was not really an acceptable change to a lot of people. And it definitely caused more than a few issues. In that scenario, maybe it shouldn't have been changed. But let's say you have a project that is yourself and a small team, and you make the decision that making this change here is going to realistically only involve changing these couple files. And it's going to have a fairly minimal impact on the it's going to have a fairly minimal impact on the overall effect of your program. Or maybe it will have a large impact, but it's something that you have predicted, you know what it's going to be, and you can change and work through it. And you've set aside some time to test the change to verify it works. In which case, maybe you do make the change because it's small enough. But let's say this program is 20 years old. This was a code block written, 10 years ago by someone who no longer works at the company. Maybe you don't change it. It's very much it depends. And ultimately, it comes down to a judgment call, right? Like, does it make sense to incur what we would refer to as code debt by continuing to pack around our unusual behavior? Or would it make more sense to us for us to go in and fix it and potentially introduce some new issues as a result? But it's a really good question, and it's
So in a case,
go for it.
in cases like that, you practically just want to copy the section and pull it out, and then make the sub action to see what the result would cause, and if it's a bad one, then just delete it, and then repaste the old code that was in there.
Very similar, yeah. So what I would do in that scenario, and at least what has been done at some places I've worked at in the past, is we would go ahead and fix the bug, and then we would test the application, oftentimes automatically. There's tooling in place to automatically test applications. And we would verify that the behavior is what we expect. If the behavior is not what we expect, then we don't really have a choice but to either keep the behavior in and implement a new function or method, depending on the language, that has the corrected behavior. And what we would do is we would do something called deprecate. So we would actually deprecate the old method, function, class, whatever it may be. And we
What is
would...
deprecate?
So what deprecation means is it's a acknowledgement in the program or in the code that this feature is no longer being developed. It's no longer being
Okay.
maintained. So by marking it with that, you encourage developers, both external and internal, to go in and gradually migrate away from the old implementation to the new implementation. Yes, exactly. Oblivion has added a comment that says, after a few minor or next major update, it'll be gone. So it's a heads up. Now, that being said, there are occasionally cases where some platforms and languages will leave a deprecated function in for 10 years. Those are the exception rather than the rule. But yeah. Most of the time, it's a notice like a couple major versions ahead. So you might have like anywhere from a few months to a couple years to patch it. But yeah. Hopefully, does that answer your question?
Yeah, that's fine. I was just trying to figure out, because you were mentioning about not modifying the base function to kind of like
Oh,
move forward off
yes.
of it. And then I was
That's kind of
like,
one of.
so if you're making
Yep.
like a sub action to try to fix the base, like would that be better or would you just leave it?
Ideally, in a perfect world, if you had the opportunity to go in and fix everything, you would go in and you would change the base action and fix the behavior that is occurring. Because by nature of you in fixing it on the inherited level or inherited classes, you're going to have to duplicate that fix in every class that goes down, that is, inherited. Or you end up in really weird situations where you have a class whose entire existence is just to fix bugs in the class above it, which is, I've seen that used, and there's been scenarios where it made sense to be used. It definitely is not very clean and it's very confusing. But yeah, no, in a perfect
Okay.
world,
But
you
yeah,
would
that was just
fix the
mainly a
main class.
question.
Oh, go for it. I
I was
apologize.
thinking more along the lines of like risking a collapse, so that's why I was trying to figure out like if it was gonna be a
Oh,
positive or a negative effect.
exactly. I mean, it depends, right? It also depends on how much time do you actually have to implement it, right? Like sometimes, end of the day, it just comes down to I need to put this change in by next week because this change needs to ship out to a customer. Like sometimes that just is how it is. Like I need to implement the feature, I need to fix this bug. I don't have time to do a rework. Sometimes that's just how it works in the field. Um, Most good companies and good teams will allocate time to properly clean up and fix code debt and prior issues. And by code debt, I'm referring to prior design decisions that have made the code base significantly more complicated than it needs to be. So most good companies and good teams will allocate at least some time for it. But yeah. Like if you want an example on how that would be addressed if you found an issue in such a class, you would, if this wasn't, say, a formal workplace setting, right? Like what I would end up doing is I would look at it and I would present both options to the team I'm on, and I'd say we can either fix it here or we can work around it. If we fix it, here's the impact I expect. If we work around it, here's the issue that we're going to have down the road. And the solution may be, okay, we're going to fix it now and we're going to spend the time on it, or it might be we're just going to work around it for now and we're going to make an effort to go patch it in a few weeks. Yeah. Hopefully that clears up a little bit. Fingers crossed.
Yeah, that makes sense. I guess you.
Cool. It's a really good question. Like it really is. It's one that comes up a lot in the industry. All right. So here's a good one. And I'm pretty sure a few people have already done this during the duration of this class in the workshops, but you don't necessarily have to have all your code in one file, right? In fact, you probably want them to not all be in one file. It makes it a lot easier to figure out what's going on. So like, for example, you probably want to split the code up a bit. So like, let's say I have a method that is in place that is purely a utility method. It's intended for me to not have to repeat it every time. I might create a file named util and I may put it in there, right? Or let's say I have a collection of methods slash functions, right? And those functions are delegated to a specific area. Let's say they're working with strings, or let's say they're regarding math, right? I would create a file for each of those and contain my respective methods slash functions in there, just to make it a little bit easier. In Python, this is referred to as a module. And you would import this module in your other files, and you'd be able to call the code in it. Like, for example, let's say, let's take an example here. So I just gave an example on the previous slide. All right, fair enough. So I guess another example would be if I wanted code to control a world map, right? I could also put it in a similar area. Same logic applies, right? So to load a module, it's actually fairly nice. So here's one way to do it. From module, so in this case is the folder name, and this should be the file name. Import the method/function. I want to load it in. So for example, let's say in utility, there is a method called generate percentage. This will import that method into our program so we can use it. There's probably worth a little addition on this, but this is the same logic that is followed, or at the end of the day, it's the same general concept. If you load something like a library, right? Like if you load something like NumPy or Pandas, right? Like in those scenarios, that is effectively the same thing. You are importing some code, and you are basically calling the respective methods inside your program. So I've actually gotten this wrong a couple times in presentations. But yeah, in general, when you're working in a programming language, you want to follow the conventions that are in place. And this is mostly just for readability. If you're working in the language and someone else is working in the language, they're going to expect certain patterns, certain variable naming conventions, certain design decisions that align with the language. So like, for example, snake case for Python. Variables should be named with, well, underscore between them. And some of these are very commonly used. Some of these are not. So like, for example, kebab case is, basically a hyphen between the two. Pascal case is first letter of each word capitalized. Camel case would be the first letter of the first word, lowercase, first letter of second word and following words, capital. Snake case is just all the words with a underscore between them. In some cases, you'll end up with scenarios where it's like, okay, please use this casing in this scenario and this casing in this scenario. Most times for readability, sometimes you'll end up with a language that's, well, where it's not exactly optional the way it's implemented. But in the case of Python, it's just going to look weird. And here's a fun one. So if you have a warning in your code, you probably want to address it. So, for example, let's say I am writing a program and I see a warning that tells me that this piece of code is unreachable. In which case, I probably need to address it. Sure, the program's probably is going to run and it's likely going to work. In fact, it might work perfectly, but perhaps one of these days, somebody's going to go along working on the code, not realize the warning's there, and break something. Or perhaps your warning is on something like a missing indentation, such as in our example here, in which case you're probably going to crash the program. And your development environment is effectively warning you this is going to happen. In other cases, in certain languages, especially languages that are extremely nuanced, what you will find is sometimes these warnings are specifically to handle really unusual bugs and or edge cases, right? Like if you'd like a fun exercise in warnings that can be thrown in a language, look up JavaScript's warnings. For example, there is a warning that will be thrown on some configurations that is a double equals or a triple equals. 95% of the time, they'll do the same thing. It's the little tiny edge case where they don't that causes an issue. But yeah, Do we have any questions so far on this? All right, I will continue. And this is one of my favorite ones. Complexity is not always a good thing. In fact, most of the time, it's not a good thing. So, in many cases, the simplest solution is actually going to be the best. Mainly because the more complex your solution is, the harder it's going to be for you to keep in mind what exactly is going on, as well as everyone else involved who's looking at the code. There are scenarios where complexity does make sense. There are a lot of scenarios where it doesn't. There is a principle, there's a design pattern for this, and the design pattern for this is referred to as a KISS principle, which basically means keep it simple, stupid. And it's very easy whenever you're looking at all the tools you have being like, oh, I can put this code in a file. Oh, I can create a class here that extends this class, that extends this class. Oh, I can create 15 methods for a scenario where one method will probably get the job done. And will probably be readable. It's very easy to overcomplicate your program. In those scenarios, you may have actually made it harder to read. Good little note to end on. Are there any questions? Go for it.
So is it calling me stupid or is it calling the context stupid?
Good question. So the principle itself is more of just a general design term that's used in the industry. The phrasing is it's referring to the developer in general. It's not a direct statement towards anyone in this room or, yeah. It's just a general, it's a general saying in the industry.
Yeah, I was just trying to make a joke.
Yeah. Exactly. Yep. Yeah.
Oh god.
Rubber duck being talking to an inanimate object. Personally, I talk to my cat. He hasn't started talking back yet, though. Kind of hope he doesn't. That would be a very problematic day. But yeah, no, like not uncommon in industry for like somebody to talk with someone else about a problem, even if the person doesn't understand the problem at all, or talk to an inanimate object, or talk to an animal, to basically express their thoughts on what's going on. And after talking it out, they may come up with a solution to their problem. Hence the term rubber duck, because, you know, one of the things you could talk to would be a rubber duck. As of recent, been learning a lot of new technologies, and so often I have a question for a main dev, then I explain it and get answer X. Yep. Exactly. Yep. Just the process of talking it out and explaining to someone what's going on is very helpful for problem solving and figuring out what exactly next steps are, right?
Yeah, I love the power of a brain.
Yep. Strange as it is, it's actually it's actually kind of a nice thing of working with a team of engineers is you have the opportunity to have a casual conversation about a technical problem and Sure, they can weigh in on it, but just by explaining it to someone who is also understands the issue, even if they don't understand it entirely, is very helpful for actually figuring out what the problem is and figuring out a solution, right? All right. Do we have any other questions? All right, well, that was the last one on this. I guess have a good one, everyone. Take care. Well, we still need to work out a detail on that, but I'll mention something in the Discord.